Hi, my name's Luke from .mesh, and today I'm going to show you Dotscience, which is a new project to make data scientists more productive. It allows them to version and visualize the results of their experiments as they're running them. So here I have a Dotscience project called Dotscience Project that uses 4 different data dots, and those data dots are some input data from 2 different Bay Area estate agents. So here you can see the input data from the first estate agent, and here you can see the input data from the second estate agent. The first thing I'm going to do is just drag that data into Dotscience, and I do that just by clicking the Browse button. And so here I can see that there's a Dotscience drive that's shown up on my machine. And so what I'm going to do, I'm just going to go and put the first agent's data into here, agent 1. And then I'm going to put the second agent's data into here, agent 2. And this is going to act as my source data when I do some data wrangling in a minute. I'm also going to drag 2 IPython notebooks that I prepared earlier into the root folder of my Dotscience drive. And the root folder corresponds to my Dotscience project. So now that I've set up this environment, I've also got empty directories for combining those 2 CSV files together and doing some filtering on the data. And then the model, which I'm going to use a simple linear regression to demonstrate some of the functionality here. So the next thing I'm going to do is install JupyterLab. This is going to, the Dotscience app automatically installs JupyterLab in Docker for better reproducibility. And as soon as that's started up, I can just click Launch, and it will load JupyterLab in my browser. So I can see I've got 2 notebooks here. I've got all the same files, of course. I'm also going to show you that there's a new Dotscience tab that we've added to Jupyter. So we've added a Jupyter plugin. And currently that shows the different versions of experiments as you run them. But at the moment, there are no versions in that display. So let's start by doing some data wrangling. We're going to combine this house price data from the 2 real estate agents. And the first thing I do, which is Dotscience specific, is I tell Dotscience which dots are going to be used for input and output, as well as some labels that can be queried later on. So here I'm just saying that we're using agent 1 and agent 2 as input data for this data wrangling notebook. And that we're outputting the data to combined houses. So now I'm just going to import some Python modules. You can ignore this error message. It's just a deprecation warning. And then I'm going to read in the CSV from agent 1 and the CSV from agent 2, and I'm going to concatenate them together. I'm then going to randomize the rows to remove any ordering in the data. And I fix a random seed here. I could actually specify that as a parameter of this process. And I can have a look at the data, and it looks pretty good. I've got bathrooms, bedrooms, and so on. I don't need all these columns, so I'm going to drop some of the unneeded columns. And then I'm just going to check whether I've got any nulls or not numbers. Looks like everything's clean. So the next step is I'm going to save that to this combined filtered housing data CSV. And then just at the end, I'm going to print out these parameters and summary. I'm just going to use the dummy summary statistics here because that causes Dotscience to trigger a commit. And so you'll see there's now a new commit here. This is now a new version. And that version records the specific versions of the input and output data for this notebook. So you can see the input files are agent 1 and agent 2, and it's recorded specific versions of those files. And the output file is this combined houses data set here. So if we look in combined houses, we can now see that we've got the combined filtered housing data available there. So great, we did some data wrangling. That's all been nicely versioned for us. So if we come along and do some more data wrangling later, then we'll be able to see a new version show up and track the changes over time. So the next thing we're going to do is actually run our model. So I'll click play here. Now this is a different notebook. It's using different inputs and outputs. It's using the combined house data that was the output of our data wrangling process. I'm going to then just do a linear regression on this. So again, you can ignore that error message. I'm now going to read in the data from the combined filtered housing data CSV that was the output of the last notebook. And let's just take a look at the data. So let's see what it looks like. So this is finished square feet, number of square feet in the house versus the price. That looks reasonably well correlated. So does the number of bathrooms, number of bedrooms, and the total rooms. But let's start out by just doing a linear regression on the square footage. So let's start out with that. We have just one feature, so this shows that those square footage numbers are coming out reasonably. And then I'm just going to use scikit-learn to do a linear regression. I'm going to predict based on these x values, and that's given me a coefficient of determination of 0.41, which is not terrible. And then I'm going to check the root mean squared error, which is a nice number because it allows you to compare so this is a number that's sort of dollar-like in size. I'm then going to, so it looks like we're off by like $815,000. So the last thing I'm going to do then is serialize that model. So I'm going to save it so that we've got it later if we want it. You can see that the model was serialized here. So this linear regressor pickle file just showed up. And then the last thing I'm going to do is, of course, I'm going to record the parameters we used, which are the features, and the summary statistics that were generated by the model. And then I'm going to save the file. Now, as soon as I save the file, a few seconds later, you can see that a new commit is formed, and that commit has input data of combined houses, output data of the model that was generated, and it also recorded the summary statistics, so the root mean squared and the regressor score. So this is useful. This is especially useful when you use it in conjunction with the experiment tracker that we're also developing. So if we go and look at the experiment tracker for this project, then you can see that we now have a single record. We decided to select the root mean squared error as the value that we're trying to minimize in this project. And we can see that root mean squared error is pretty high at 815K. So can we get the RMSE down? Will be a comment that I'll leave here. It's also worth pointing out that we can dive into this run of this project, and we can see all of the values in a nice table here. So we can see the parameters and the summary statistics. We can also see the exact version of the notebook, including all the graphs that was used in order to generate this. So we see that we could just use the finished square footage here. What's more, we've also captured and versioned the project files, so you can see the exact IPython notebooks. You can see the exact version of the input data, and you should also be able to see the exact version of the model here. Now, let me just hit reload there. Yep. Yes, so the model has now shown up. So you can now use this sort of as a library of models that you can select from, and you can even go and download this pickle file later on. So this is pretty cool, but it would be great if we could improve the performance. So let's go back to Jupyter and let's have an idea. So we have all of these different values here, and we're currently only using finished square foot as the parameter, but let's add some more features. So we'll add bathrooms, we'll add bedrooms. So the hypothesis here is that by adding more of these positively correlated values, we'll reduce the RMSE score. So I'm just going to rerun the notebook. I'll run all the cells. So if we now look from the top, we're just re-rendering that data. This is where it gets interesting because we changed the number of features. So we can see our features table here now. And now we can do another linear regression. And if I hit save now, then it's going to record those new statistics here in a Dotscience commit. So actually that's really interesting, because when we added more features, it looks like the RMSE actually went up. So the average error rate in the experiment tracker, so you can now see that actually the root mean squared error just increased when we went from just using the square footage up to using all of those available features. So that's kind of surprising. It probably bears commenting on. And you can see here, I've got exactly the same access to the version notebook. I can see, for example, if I load this up here, if I go and look at the first run, which happened earlier, then I can see that I was just using the square footage. And if I look at the second run, I can see I was using all four of those features. And I can, again, the input data, if that changed, then that change is versioned. The modified regressor model is versioned, as well as all the project files associated with that run. Please reach out and get in touch with us. You can join our Slack at dotmesh.com and scroll down to the bottom of the page, and there's a Slack link. I'd love to hear from you and get your feedback, and let me know if this is useful to you, and you can join our beta program. Thanks for watching.